So hello, everyone. Welcome to this DevToberfest session called Troubleshooting Wrap-Based Fiori Apps in the ABAP Development Tools, or ADT. And today we're joined by Ingo Breuninger, product expert at SAP in Waldorf. Hey, Ingo, how are you, sir?
Hi, Rich. I am doing good.
Good.
Thanks for inviting me to present something here. How about you?
I'm doing well. Thanks for joining. Would you like to tell us a little bit about yourself?
Yeah, I'm now close to 20 years at SAP. I'm a product expert in the ABAP platform, and I'm working in the SAP Business Technology Platform ABAP environment enablement team. The team takes care to help customers and partners to develop and operate their SaaS solution that they can build on the Steampunk stack. And the next step would also be then to help customers for the embedded Steampunk, which is a quite new product, which is released or was released a couple of weeks ago. Yeah, that's basically my task and my work at SAP.
Cool, great. So again, Ingo is going to share with us a little bit about how to troubleshoot wrap-based Fiori apps using tooling built into ABAP Development Tools. Take it away, Ingo.
Yeah, then hello, also welcome from my side again. Yeah, troubleshoot your SAP Fiori apps with the ABAP Development Tools in Eclipse. So first of all, I want to a little bit motivate the topic, why we are doing that, giving also some evolution path where we started from, and then in between I will introduce more or less the tools that you can use to troubleshoot your Fiori app. Then I'm switching then to an application I prepared. The application is running on the Steampunk stack. I tweaked a little bit the application. We will see that, so that we run into some issues, that we can use the tools that we provide to exactly then find out what's the issue. So then, again, introducing tool by tool, switching back to the application, to the ABAP Development Tools, showing the troubleshooting tool, and then we will do that for a couple of times, and then let's see where we end up. Okay, then let's start. As usual, the main disclaimer here, do not take any purchasing decisions basically for watching this this session here. The information presented is not a commitment or any kind of obligation to deliver any code or functionality, and that's basically what we need to present here. Okay, then where's my? It's not working here. Next one. Again, a short introduction about the topic itself. Then I will then introduce the troubleshooting tools one by one. In between, we have then always the demo, and at the end of the session, quick wrap up, quick summary what we saw today, and that's basically all about it. Okay, the evolution of the ABAP programming model. Basically, we started with the previous or underlying ABAP platform, called 740 or less than 750 stack. With that, you just could basically create transactions, ABAP Dynpros, Web Dynpros, and with 740 SP5 as stated here, we also introduced CDS views. At that time, also the ABAP Development Tools were or are the only tool where you could develop so-called CDS views, and we started with that again in 740. Then in 750 we introduced the so-called ABAP programming model for SAP Fiori. Maybe some of you know that you just created your CDS models. Then you could also then enhance or create some business logic into the so-called BOPF technology. You could also then use the gateway builder, the SCGW, to create your OData services. We also introduced then in that stack the so-called OData publish to, easily consuming created CDS view as an OData service, maybe also using the reference data source model embedded into the gateway builder. And that was then with this greater than the 15.11 release. And now today we are at the so-called SAP BTP ABAP environment, the steampunk stack. Introducing then the so-called ABAP RESTful application programming model called RAP. Again, the underlying foundation for that is still the CDS use. And on top of that, we introduce new artifacts, the so-called behavior definition and the behavior implementation, where you define your behavior of your RAP BO, and of course then can implement some business logic for your RAP BO. On top of that, of course, then introduce also new artifacts like the called business services, where you just can expose the OData, for example, an OData service or an INA service or an SQL service on top of your RAP BO, basically. All the investments that you did also in the previous world, starting from 740 are safe, because you can directly reuse the CDS use on the dedicated platform, on the dedicated stack here, and exactly use then the tools that we provide in the dedicated stack here. Okay, so that was the evolution of the ABAP programming model. Then the big picture, quick wrap up here of the ABAP RESTful application programming model. So the foundation again are the CDS entities. You do the CDS data modeling with the ABAP development tools, and you can basically then also do any kind of other technology basically in an on-premise stack to fetch the data and display it in an ALV grid, for example. But nevertheless, with the so-called business object that we introduced here, the foundation again are the CDS views, the CDS entities. We introduced here the so-called BDEF, the behavior definition. And on top of that, the BDEF also brings the functionality to implement some ABAP logic in the so-called behavior implementation, and to express here your business logic more or less. This also applies for so-called analytical models. You can also use CDS views for analytical cubes and analytical dimensions, and also then implementing here your logic to exactly then later on consume the provided services on the consumption layer. Oops, wrong direction. So again, next step would be, if you have your foundation, your business object, that we introduce here so-called the projection layer, the business service provisioning layer, where you have a kind of projection view on your data model. And you can also then override, for example, different actions that you might implement here in the projection layer, and also override also the behavior implementation here. Again, also this applies also for the analytical projection on the inner services. If you just had that, and we will see that later on also in the demo, quickly introduce how that looks like. You just basically create a so-called service definition, which exposes more or less your projection layer. And on top of that, you really create a so-called service binding, where you define then here the protocol that is being used to the consumption layer. The consumption layer means that you might have some Fiori eyes on top of that. That's what we will see today. Have a really an OData v4 service that we exposed here, and on top of that we created, or I created, a SAP Fiori UI that we just can use then the Fiori layer to consume our OData services here. Of course, you can also then basically consume or create a service binding for web APIs, to have RESTful APIs here. Also the possibility to directly have an integration to SQL-based services, for example, having an Excel sheet and using the ODBC driver to consume then the data from the underlying layer. And on the right-hand side, of course, again, the analytical stuff, that you can also then use INA services based on your data model that you developed in that stack. Okay. Your tool of choice here, of course, to build all that stuff, and later on also, and the focus here is then, of course, Troubleshoot, that is the ABAP development tools in Eclipse. For me, the ABAP development tools is much more than simply an editor to do your coding here. Of course, you get some modern development tool set in Eclipse to do your implementation, to have code completion, syntax highlighting, pretty printing, and whatever. Of course, the second part here, the quality assurance, it's called here, so that you also have a kind of view to execute unit tests, to have an ADC check in place. And but not least, last but not least, the supportability tools. That's the focus of today's session, that we have a debugger, of course, integrated into the ABAP development tools. We will see the profiling, the ABAP traces. We also have some other cool tools which helps you exactly to do troubleshooting. Again, besides only doing this plain development in your IDE. All the stuff that we see today, for example, the CDS views, implementing CDS views, or the behavior definition, this is only available in ABAP in Eclipse. There is no way to do the coding besides or except or not in the ABAP development tools. That's kind of, then, as I always say, we force developers to exactly use then also this tool set here. Okay, that's it with the intro. So you just get a short glimpse about why we are doing that, where we are coming from, and where we are heading to. So troubleshooting tools. I will show you a lot of tools today in that session about doing troubleshooting. First of all, we will have the Fiori application later on that I will introduce quickly. And then we will simply use the browser developer tools, because of having exactly two facts that we get the URI out of the request, so that we can later on use that URI in the ABAP development tools, so that we can focus really on an aspect and then not to have too much traces basically in the tooling. So we will just see how that looks like, copy parts of the URI out so that we can reuse that later on. So quick introducing here. And the second fact here is if you do not have the first glimpse on kind of an ADT at hand, if you want to do some analysis here, then you can also have the so-called statistics header. I will show that also, that you get a first glimpse about, hey, maybe if you have a performance issue, data is loading too long, where data basically is wasted in the application here. Okay, short demo here then later on. Then the first tool then in ABAP and Eclipse is the so-called ADT feed reader. There are multiple tools inside the feed reader where we just want to have a look into. First of all, the ABAP runtime error log, mainly what you know from, for example, from the SAP GUI-based world are the ST22 dumps. So we integrated it into the feed reader as a feed here, the ABAP runtime error log. The second one that I will show you today is the gateway error log. Now, if you maybe know the gateway error log in the backend, the IWFND error log transaction or the backend transaction, this is also then integrated here into the feed reader. So feed reader demo showing the runtime error log and the gateway error log. Then I will show you, maybe I guess most of you will be new, a new tool, the so-called ABAP Crosstrace. This is quite new tool where we have the possibility to, for example, have the gateway trace integrated into the Crosstrace, and specifically here, most important is the RAP trace. So some parts of the ABAP Crosstrace is also built to have a RAP trace integrated into that, so that if you create your application, if you run into some issues there, that you can enable that cross trace for the RAP tooling, and then we will see how that works. Okay, then the next tool is the ABAP profiling. So if you have later on some performance issues, basically I will use that. If I want to check the performance, then I will use the ABAP profiling tool. Give you some glimpse here, how that looks like. And last but not least, also quite cool or helpful are the CDS tools inside the ADT to get also some information about if data is not displayed correctly on the Fiori eye, how you can basically use these kind of tools to do some kind of troubleshooting stuff. I will not show today the ABAP debugger feature. I guess that most of the ABAP developers already know how that looks like. Also, if you are using the ABAP development tools because of the sake of time today, I think we will not get all the stuff shown here within the 1 hour today. For completeness, there is also the possibility for on-premise systems to also have to set some dynamic log points with the ABAP development tools. This feature is only available today on the on-premise stack, not on the Steampunk stack. So we also I will not show that today on our demo. But again, for the sake of completeness, I also mentioned that here on the slide. Okay, Then let's start with the first tool, the browser developer tools. So before we go to the first demo, then I will also introduce a little bit or quickly the application that we have, show you the artifacts, the RAP artifacts that I created, so that we get a quick glimpse on how that basically looks like. As I already mentioned, the SAP statistics header, we will set that in the OData URI in the request, so that we just have then later on a kind of SAP statistics here, the total time that was consumed on the backend side, for example. So if you have one day and performance issue, that you can focus here on exactly that aspect, without logging on to ADT, logging onto the system, so that you see, hey, time is consumed in my application, and I need to maybe have a closer look here by using then the ABAP development tools. Okay, then let's go to the application. I will go to, then I of course got now a timeout for my application, maybe just refreshing that here. So again, we are here on Steampunk stack, so in the SAP Cloud Platform ABAP environment. I created a small reference application. The reference application is about that I have business partners in my application. Maybe just opening that app quickly, where I have, again, business partners here with an address and an email address basically behind that. So that's a really small data model. On the other hand, I have a product. I also maintain there 8 products here in the system. And last but not least, and we will just use this application, the customer order, to exactly then do and show the demos of doing troubleshooting for this application. Again, I tweaked a little bit of the application here so that we can run, or that we run into some issues, that we can use the tools to exactly then show this one. Okay, so let's do that. So we have a customer order here. The customer order basically has some order items, and each of the order items have some kind of pricing conditions. You might know that from the ERP data model. I call it price summary. And then, of course, if you do any kind of change, then the price will be recalculated. We will see that in a second. If we go to the application in the ABAP development tools, how that basically looks like. So this is the application. And then again, we will do some modifications here, change the data, and then again, run into some issues. Okay, so going back to the application on the ABAP development tools. So what do we have? We have a so-called behavior definition. We can open that behavior definition also then in the so-called Relation Explorer, show in the Relation Explorer. That will take some seconds to load. And with this replication in this Relation Explorer, you basically see what is in, what our behavior definition looks like. So we have some standard operations like create, update, delete. We also have some determinations inside. If we create a new sales order, so that I generate a UUID for the sales order, for the partner ID, whatever. And then of course we have some draft actions. I did not implement them yet, but basically you are able to exactly do that. That's the customer order, business object. If we go then down to the customer order item, you will see that we have an association, for example, from this custom order to custom order item here. This is exactly this one here. And then inside a customer order item, we also then have a association to the price summary here. If we go to that one, and then this is exactly our level 3 line here for the pricing here. And inside that customer order item, I also implemented a determination here to do exactly this price calculation. And then again, we will then see exactly in this method several issues. If you calculate a price, that we have a dump, that we have a performance issue, that's all implemented more or less here in this calculate total price. Of course, you can also navigate directly into that one, that we see, hey, some of the stuff is calculated here. We also then do some pricing engine to exactly get some discounts here, and later on, we see that we have a performance issue here in this pricing engine, calculating the discounts here. That's more or less about the BO. As I said, we have the underlying foundation for that is, of course, all the CDS views that you also saw here. Our BO here, the customer order. And then on top of that, I created the consumption layer. Yeah, this is this one. This is the C layer, the projection layer. I also added then some UI annotations here. Of course, basically, you can also add that into the metadata extensions, but we will come to that in the CDS tooling. Why I also added here this in the consumption layer. Basically, you put all the information here in the metadata extension. Okay, then the projection more or less is then that we created, or that I created a service definition here for our customer order, consuming or exposing all the artifacts into the projection layer. And on top of that, I created so-called service bindings. In our case, I used the OData v4 service. And on top of this OData v4 service, I created a Fiori UI. Of course, you can also create then some API, web service-based, REST-based services to be consumed, SQL services or INA services. That's what you basically saw on the slide here. But today we are focusing only on the Fiori part, having a UI service exposed to the outside world. Binding type OData v4. Okay, so I will close that again. So let's go back to the application, starting with the first issue. For example, if I now go to the edit mode, if I navigate to the pricing condition here, and again, I tweak the application. So if I now put here some fancy value, and if I now say apply, we should basically see an exception, a short dump, so that something is not working on the backend. And you also noticed, because in the backend, in the background, I had my ADT open, you will see that the message from the feed reader is being displayed here on the ADT, and you can basically go into directly into that short dump. One quick remark, as I said that I will not do a demo for the debugger. One small cool feature is that you also have, if the feed is displayed here, the possibility to open the debugger in a kind of post-mortem way. So if you click here, that one, the debug, is not reachable. That's basically bad. Okay, I'm not sure why this happened. Basically, you can then directly click here on this debug icon here. Maybe let's try it again. It's really bad. Do it again. Debug. Yeah, now it's popping up. Not sure what's happening here. That you then directly jump into in a post-mortem way, opening the debugger, seeing where your stack was, so, and also then having the variables that are displayed here loaded, so that you see in a post-mortem way what basically happened. So in this use case, my price that was calculated. So by doing the currency conversion, something happened here in the currency conversion. You can also have the possibility directly integrated the post-mortem debugger into the feed here. The feed reader itself, so let's kill that. Terminate and remove. Yes. So the feed reader exactly is a kind of view. So basically, if you do not see the feed reader here, you can press Control-3, search for feed, and then you can open the feed reader here. That view get opened for your dedicated system, and you see that we have here runtime errors. Now that's exactly the one that was caused. You can basically click into that one. You have a preview here, what happened. You can also double click here and then directly see what was going on, the reason for your short dump. So objects were not convertible. You can scroll down, see then the code where this happens. You also have then the call stack. For those of you who are coming from the on-prem world, there's a second tab here, the so-called long text. If I click that, you might be much more familiar with the stuff that you know from the SE22. That's exactly the formatted way of the SE22 view. And if you scroll down here, you exactly see the same information and also then more information about what was really going on the kernel side. That's more or less also for then our kernel developers, if you are interested in that one. Basically, I like that view here. That's more or less the stuff that I need. And you can directly also go to the source code extract where this happens. If I go back to the summary here, have the active calls, then I can basically go here into my into my currency conversion routine. Yeah, and of course, I tweak the application. Yeah, that this happens. Yeah, just changing that one so that we just take the right type here. Save and activate that one, and that's it. Yeah. So fix the first issue by using the ABAP feed reader runtime error. And so if I now go back to my application and saving this one, yeah, we should not get an error again, and the price is calculated, yeah, up to the customer order item level, and that's it. Yeah, so saving this one, and that's it. Okay, next issue is that we just change here the unit of measure code. And again, also here, I tweak the application so that we run into that issue. So basically what now happens if I save that one, that we get a gateway error. This is not handled by the application itself. On my coding, this is also checked by the gateway layer that the quantity is here valid. And if I do that, and I will have no configuration for the unit of measure because of, if I now go back to my feed reader, I go to the feed, I have here the gateway messages here. Opening that one, refreshing that one, we'll see that we get 2 new messages. Why 2 new messages? Because the Steampunk system here is a so-called co-deployed gateway system. So we have a front-end part of the gateway layer, where the message is being displayed. So in an on-premise world, you might also have a dedicated front-end server and then multiple back-end servers. So be careful of where you are connected to and which one you are seeing here. Again, I see 2 because the front-end and the back-end is on the same server. And of course, then the back-end error that was caused here. If I go to that one, going here to the application, so raising here the exception in the method, so reading the unit of measure code in the T006 table. Again, I forced that one so that this happens. Basically, you will not run into such issues. But to see if something happens directly in the gateway stack, that you also have then a dedicated gateway error log here. If you want to create your own feed, you can also do that. Just right-click here on your system, add any kind of feed that are supported. For example, if you run ATC checks, that you also then get feeds if some ATC checks are running in the backend. That you got also the ATC findings are displayed, or any kind of BW job repository, or any kind of other errors. What is also quite cool is if you want to check or edit the feed, you can also then add a date time, that I only see short dumps that basically are later than, and also that you also have the possibility to directly get dumps from the system if you are the package owner, if you are responsible for some objects, if you have a development team and you want to get notified if colleagues of you run into some issues, then that you can also then being notified if you say, hey, if an object produces a short dump you are responsible for, then you see that directly in your IDE. You can double check why this happens and so on and so on. So really, really cool. Okay, that's about the feed basically I wanted to display. So really helpful from my point of view. First starting point here if you just have some issues in your application like we just saw here. Okay, then let's going back to the next one. So again here the summary about the dumps and gateway error log. So what is the intention of that, why we are providing that one, and that's it. Okay, then next one is the so-called Crosstrace next tool. The Crosstrace was introduced also because the colleagues from the RAP development teams asked us to exactly have a tool where they can basically integrate into a generic tracing tool to doing also their support. And we will see that how cool that is. Also, if we are developing a Fiori UI later on. And I will quickly then introduce that. What is also quite cool is that in the Crosstrace, you also get the possibility to have the gateway trace integrated in the Crosstrace. We'll see that in a second. The first demo I will show. And this is also quite cool that you exactly see what's going on, what data is sent to the backend system, and the response then directly again to the client, to the UI. For completeness, I put in here some information about the scope of the tracing tool, screenshots, how that looked like, yeah, so that you can then enable dedicated so-called sub-technologies like the SADL layer, like the gateway layer, like the behavior definition layer of all the different frameworks that are interacting within the RAP application, yeah, in the implementation. Okay. Then I think more important is then the demo. So let's going back to my application. So going back here. To that one. Yeah. So first of all, what I basically do is, and if we now go to the RAP trace, is that we in Eclipse have a dedicated perspective for doing, let's call it the ABAP profiling. It's also called ABAP profiling perspective. For those of you that are new to ADT, so what is a perspective? Yeah, so we also saw that the debugging perspective here, yeah, so that you simply have different views to do your job. Yeah, for example, in the debug view, I need some kind of variables or the breakpoints, yeah, that I set in my application. And also that we also then have the so-called profiling view because of the sake of doing our job, doing profiling, doing tracing. Yeah, this new perspective was introduced here. If you open that the new perspective, again, how to open this perspective is basically going here, Control-3, and saying then ABAP profiling, and then you just can basically open that perspective here, ABAP profiling. Then we see here the ABAP Crosstrace. Yeah. Within the ABAP Crosstrace, maybe resize that a little bit. Yeah, we then see all the systems that I have in my development tools configured. I closed all of them. Only one system here is active. Yeah, that's my steampunk system here called X11. And if I open that one, yeah, I see that the trace configuration here. And if we simply create a new configuration, that we get the dialog, yeah, to exactly create such an ABAP Crosstrace. What you see here is the different frameworks, yeah, of the RAP programming model for the sub-technology. What was also introduced in this release was also that we have now also Crosstrace for body calls. Yeah, so if something implements a body and you run into some issues, you can also then trace the call of the body. We will not see that today. Yeah, we simply focus here on the RAP specific part. You're having the BDEFs, the SADL, the CSP, DSP, and so on. But first of all, I wanted to show the first demo about having simply a gateway trace. And so only enabling the sub-gateway trace here. What you can do is basically also then gateway trace is giving a description. Yeah. In the request entry type, you get a list of what kind of request entry types you want to trace. Of course, here the transaction is not really useful here in the steampunk system. Yeah, so we want to focus only on OData v4 calls that are fired against the system. Yeah, you can also then have a report basically in an on-premise system or an ABAP daemon. Yeah, you can also trace an ABAP daemon. Again, we also want to focus here on the v4 part. Okay, then let's do that. But first of all, I wanted to show you some ABAP some tracing tools here. So first of all, what do we want to trace here? Yeah, so let's maybe reload the application here. Let's start the recording. Yeah, refresh the application. Yeah, then we see here a lot of requests entered up. Yeah, so let's focus on sub OPU OData calls. Yeah, that's only the calls that are fired then to the backend system. Yeah, and if we now open one of the calls here, the batch request, then you see here that we have here this URI, and we also later on want to only have the stuff that is for our customer order. Yeah, so I simply copy over this URI here. Maybe we simply store this one. You do not see it here. Yeah, store this URI so that we can copy paste it over to the Crosstrace, and that's it. Another cool feature, basically, I missed that one, sorry, is the so-called sub-statistic setter. Yeah, so I want to quickly enable that one. Yeah, call the sub-statistic setter. If I now reload my application, you will see that we will have a new response header field in the response, indicating what time was consumed on firing the events against the Steampunk system or to the backend system, to the ABAP system. So doing that, loading again the application, then you see, hey, that the new URI parameter was entered here, so called substatistic equals true. And with that, you get some information how much time is consumed in the different layers on the ABAP system, like the ICF, like the gateway layer. Also the app time, that is your time that you are basically responsible for during the implementation. If there is a really high number or performance issue, then you have a first indicator on what's going on, where time is consumed directly in the stack here. But again, so we copied over the URI here from the from the browser tools. And then let's going back to my ADT here. Let's paste this URI here. We need to use wildcards. Oops, that's the wrong one. That's my URI. This one here. That's the URI that we want to focus on. And if I now activate that, then only the URIs or the request with this URI will be persisted in the Crosstrace. Number of traces, let's keep that on 20. We can do that. So let's do it. So the first thing is now that we reload again the application. It will take some seconds because also the traces need to be written into the database. So, and if we now go back to the trace results here, and if we do a refresh, then we see that we have 5-6 requests here. First of all, the first request that was fired against the system is some metadata about the OData service itself. If we now double click here, we exactly see what we basically know from the gateway trace in the backend system. That's the URI that was fired, with all the header fields in the trace, and of course, if we now going back to the response, that some information is handed back here. So we also always have in the RAP trace in the result, if we're now opening this RAP trace, an open bracket, so to say, and the closing bracket. So that's the request for this one and the response. Now, if I go back to the Crosstrace here, for example, if we go to the next one, the head trace here, the head request is fired to get the CSF token out of it. So if you open this one, you will see that in the CSF token response header, where is it? Fetch basically is used here to get the XCSF token back from the ABAP system. And if you're going to the response of that one, you will see that the CSX token was now handed back to the UI, and so that we can later on then use this XCSF token to do the next post or a post request here to modify some data. That's basically all. One of the requests is also then, I think this one, to get the data for our application itself here. That's the request fetching it's a batch request here that we see, the HTTP body in the request to get the data for our customer order with the ID 2. That's exactly the one that we are seeing. And there's also one request for the complete list of customer orders. I think that's this one here. No, not this one. Then it's this one. And because also the data of all the customer orders are directly loaded in the background. And so all the customer orders are loaded here. No, it's not this one. And let's see. They missed one. Okay, anyway, so one of the requests basically should hand back or return all the orders from the list that they are already loaded here. Okay, so a quick summary here. Then you can use the ABAP Crosstrace to exactly then use this as the gateway trace that you might know from the backend system. Okay, let's close this one. Close all. Let's also deactivate the trace here for the gateway trace. So let's create another one. Yeah, a normal RAP trace here. So create a new one. So let's call it RAP trace. And we will now turn on all the RAP specific frameworks here. Also 20. Yeah, URI is again OData v4, focusing on exactly our URI that I copied over here. Yeah, called RAP trace, also 20. Let's do that. And let's deactivate that one. First of all, let's going back to our application. No. Where is it? Here, going back to our application. Yeah, saving here, for example, that the amount here. Yeah, the quantity here, and yeah, call it 1, 2, 3, 4, 5. Yeah, and before I now save that one, I will activate the trace. Yeah, so that we only get that kind of request here. Yeah, activate it. It's active. Yeah, active. Save it. Again, it will take some seconds. Yeah, and if we now deactivate it, go to the trace results, we should now see two more requests here with the so-called RAP trace. Yeah, and one of them is exactly the saving the data to the database. Yeah, so if we now open this one, maybe resize that a little bit, and you can directly open the complete trace request. Then we see the complete orchestration of what happened during the execution of the business object of the logic. And so that we have the processing our change set, basically. All the stuff that is highlighted here in yellow basically indicates that you are responsible for that one. Yeah, you see that we have this customer order item validation of the quantity. I implemented there a short validation that the quantity is not a negative quantity, and then you basically see the complete flow of what happened inside the RAP framework. You also see here the components that are involved. Yeah, for example, the CSP, the SAT layer you might know, or the behavior definition layer. Yeah. And so you again see what happens. Yeah. So for those of you who are familiar a little bit with the RAP programming model, yeah, you also see here the save sequence, yeah, the finalize, check before save, adjust number, save, yeah, the save sequence. What is exactly what is also done documented, and basically you can also implement then each of this dedicated method here, yeah, to, for example, having the adjust numbers, yeah, getting a number from the number range value that has to be set then in the dedicated method to basically implement it. Yeah. So the complete flow, what's going on inside the framework. It's not really interesting here because nothing happened, yeah, because we do not have an issue here currently. Yeah. If you are interested in that, you can basically do that. You can also adjust the filters here, yeah, for example, only focusing on the sub BC CSP layer, for example. If you're only interested in these kind of messages, yeah, it's interesting again also for our colleagues here internally who are then doing support if something happens. Yeah, and you also can have the filter and also only then displaying the CSP records that are part of this complete execution flow. Okay, again, not really interesting. Yeah, now let's have a use case where we run into some issues. Yeah, something happens in the application, then again turn on the RAP trace to get really a helpful tool what happens, and that we just can fix that issue. Okay, for that I'm going back to the application. Yeah, so let's edit here. So I want now and enter here a negative quantity. Yeah, and you will see if I do that we get an error message. Yeah, so negative quantity is not allowed in my application. I can also then use here the navigation and directly being navigated, yeah, from the Fiori tools, from the UI to what is going wrong here. If I enter another negative quantity here, -2, yeah, and try to save it, yeah, and you will get 2 entries here, yeah, so that the negative quantity 2 is not allowed. I can navigate here or directly going into the 1. Yeah. This is really helpful if you have a much more complex UI. If something happens here that you have a big screen here that you can directly navigate here into what's going wrong. Okay, but somehow, if I now enter -123, yeah, if I now try to save that one, yeah, you will see that I get the error message, but I cannot navigate into it. So somehow my UI now acts a little bit different, yeah, as expected, yeah. So something is weird, something is wrong here. Another question is what's going on here? Why it's not doing the behavior like I basically did, or that we see 2 seconds ago, yeah, so that I can navigate into that one. Yeah. So for that, let's turn on the RAP trace. So going back to the trace configurations here, activate again the trace. And now saving this one again. Will take some 2-3 seconds longer. Yeah, so done. Let's going back and turn it off again. Going to the trace results, we now should see another result here. That's the last one here. Yeah, exactly this one. And if we open that one, yeah, you will see that inside the RAP implementation, we will have here a record with the failed one, yeah, that it was reported, the one, yeah. And now let's double click here on this entry to see what is going on inside the RAP framework, why the behavior is a little bit different than expected. Yeah, we'll see that I use the so-called stage area in the RAP programming model, yeah, to put the messages into a section, yeah, into the stage area. And basically what I did here is that I put all the validation of my quantities, because it is implemented, of course, in my validation of the quantity, yeah, is not there. Yeah, so the area for this, all the line items here are wrong. But I have an entry here in this record, yeah, where I see that my stage area is not the validated quantity, but it's called demo, and the message here is written into a stage area, which is, yeah, not the right one. Let's put it that way, yeah. And that's exactly also the reason why this fails, yeah. Again, this I tweaked that a little bit so that we exactly get into the point, yeah, where the RAP trace could be really helpful, yeah, because we see really here the internal stuff of the RAP framework, yeah, all the variables that are basically inside the processing this request here. Yeah, I can also directly navigate into this one here to see the coding. Yeah, that we see here, this is my validation, that I implemented here, and inside that one, we see that I created a so-called stage area with the name validate quantity. Yeah, so all the messages are put into that one, but somehow, again, I tweaked that one. Yeah, I now put the message here for that one into a stage area called demo, which is not existent. This is not there in my model, yeah, because only the validate quantity, of course, is there. Yeah, and that's exactly the reason why this message is not handled properly inside the Fiori UI, so that you can navigate into that one. Yeah, this is one sample, yeah, where this could be really helpful. The RAP trace itself, of course, is an expert tool. Yeah, you need some time to get into it. Yeah, to read all through that, how to handle that. Basically, yeah, it's, yeah. Again, you need some time, but once you understood what's going on there, yeah, that you can double click, for example, what's happening here. Yeah, also interpret all the values that are there. Yeah, if you programmed within the RAP programming model and the framework, then you know what means basically all the values that are traced here during this execution of such a request. Yeah, but again, one sample that we saw here is that I use here a wrong stage area, yeah, where I put the message into it, and that was exactly the reason for this one. Yeah. Okay, that's about this one. So let's save it. So it's working now. That's a quick intro into the RAP trace, and then of course the gateway trace as well. Okay, then coming to the next one. That's the so-called profiling. Yeah, so if you might run into some performance issues one day, then you basically use the profiling trace to exactly get some insights where time is consumed, and that's what we want to do now. Yeah, so let's create a profile, trace request, and trace it. The tools also here for completeness, I put all the tools that we will also see in a second into that one. So going through all of the tools here that are listed here to find the top consumers in regards to what was executed. I have that call timeline view. Also see a kind of SQL trace, the call stack, and so on and so on. Again, I will switch over to the demo. I think that's much more helpful how that works. Again, going to the ADT tooling, again, close all that stuff. For the ABAP profiling, for the ABAP trace, we also have then a new view called ABAP trace. Now we'll go here again to this one, create a trace request. Also ask the colleagues why not to integrate a trace tool into one view. But maybe we will get that one day. Again, we will also focus on the URI of the sales order, again, the one that I copied over from the browser. Also focusing on a web request. Also here, you should also can use the, for example, having a transaction or report that are executed tracing. Again, you want to only trace here the web request for exactly that URI. Number of trace files, maybe just also put here 20. Save that one. Then there is also a kind of parameters that you can maintain here. What you basically want to do for those who are familiar with the SAT trace, because that's more or less the SAT trace that's is used in the backend. Of course, only a different UI here. You can then basically put on or switch on whatever you like here compared to the SAT properties. Okay, let's do that. So let's go back to our application. If I know, first of all, I should have save that one or edit this one, so we get now a lot of traces here. Let's see if we find the right one. So first of all, I put here a net value again with number 22, and this should basically take some time to being executed. I should have shown you that it's basically fast and will take some seconds. If we do something weird again with this famous number here, something happens in the backend. And again, I tweak the application so that we run into the performance issue. Let's apply that one. You will see if we save it now that it will take some time to being executed. And if we now go to the ABAP trace results here, hopefully that works, that we have a runtime, a long one. That's exactly the one that I expected there, 1.5 seconds. And if we open that one, then we see that we have a huge time of database consuming time. You have here in the overview list of this trace record here, a list what happened. Also quite nice. A graphical overview here where time is consumed. In our case, it's a database runtime. Why this is the case, we will have to find that out. Basically, what I do is I always then use the so-called condensate list. The condensate hit list is to show the top consumers aggregated to call units. This will take some seconds to load, and then we will see that we have an huge execution time within my pricing engine. Exactly the most time that is consumed over 60 or close to 60% is in this pricing summary method. 264 executions happen there with a huge own time basically there. The question is why this happens why we do have so many executions here and also the time that is consumed. Basically, what I do here is that I display here this in the so-called hit list. If you right-click that line here and asking to show it in the hit list, you will see that we have a lot of positions where this pricing calculation is called. It will take some seconds. So we have, I guess, 12 positions where always the same method is being called 22 times. You can also directly navigate into such a line and you see, hey, the get price for the get 1% discount is called. Or another one here that we also do a get 3% discount is called. Of course, I know, this is a little bit weird that somebody is doing that, but to show you the functionality of this ABAP trace here, how that basically works. Yeah. So I'm always calling every time, every calculation of the discount, nevertheless of which discount should basically be applied. Yeah. This is how basically it works. Yeah. You can also then use that entry here in the Condensate List to show that also in the aggregated call tree. Yeah, this is more or less the same view here, but if you now double click into that entry, you just get up into the editor, where you directly see the complete call tree. Yeah, let's do that. You see where this position is now being executed in the call tree. That's the difference here. Okay, the next one that basically I like to show is the so-called call timeline view. So this is an overview about all the stuff that's happening in the system. Now, if you open that first, you basically see the so-called called by type. Here you see where time is consumed in our use case here. Yeah, all this is our ABAP methods basically here, but we have one section where we have also kind of database records here. Yeah, a lot of database records. And the cool part here is, if you know how to read that, is you basically have a visual interpretation of what's going on there. And if you always have a lot of reoccurring patterns in such a view, in such this editor, yeah, then you basically know, hey, that something is going wrong, that something is again and again and again executed there, and that's always an indicator that something is going wrong. Yeah. So this is the first part basically that you see right really quickly. Yeah. Always doing the same stuff, yeah, and also having the database access, yeah. So having a single request to the customer order table, customer order item table. Yeah, maybe if I scroll a little bit here inside there, move over, yeah, that, yeah, you see that there's a DB fetch, yeah, from the customer price table there again and again and again, and that's the reason why we have such a high database time for this request. Yeah. Another cool thing is if you just change here the object, the diagram by, not from call type, by the object name, you basically have the possibility to editing the coloring scheme. I have here a small bug, yeah, that you can basically focus on only the things you are interested in. Yeah, for example, my application is implemented in a namespace called ATAPC1. Yeah, if I simply use that one, yeah, I see, hey, this is my coding I'm responsible for. You know, all the stuff that is now yellow colored, I'm responsible for. You know, this is not framework time, that is my time, the app time basically. And so this is quite cool to have a coloring scheme, yeah, that you just can see, hey, where time is consumed by the pricing engine, by whatever. So really helpful if you want to exactly do that. Or for example, if we now again change the color, yeah, having where is the behavior definition basically, yeah, in here. Let's do it that way. Yeah, for behavior definition, I guess this is the one. Yeah, so behavior definition always is used here. So that's quite cool exactly to get into the details here. Yeah, of course, again, this is a quite simple sample, but believe me, I did that in the past weeks and days and weeks and months, yeah, to analyze the performance of the dedicated frameworks to get better and better and better. Yeah. Okay, that's my last part. Sorry, I missed that one. Database access. Yeah, there's also then the last view here, the so-called database access, where you see what table is being accessed during that trace. Yeah, be careful. This does not replace the STO5 trace, the SQL trace. Yeah, this is simply that you see what table, what table is basically being read. Yeah, or from the backend, from the database table. Yeah, or from the database. Yeah, also then you also see here the customer price is always read here, yeah, also with a select single. You know, if you really need that, yeah, you have to think about that, and that's why we have this this high consuming time here. Okay, then coming to the last part. Yeah, I think we are running a little bit out of time. Let's going back to the presentation. Last part here, and also the demo is about the troubleshooting tools for CDS use. Yeah, so we have here a lot of tools inside that So the data preview, of course, the annotation propagation, the active annotations, and we'll quickly show that. Also for the sake of completeness, I'll also put it here into the slides there. What is the dedicated scope for this CDS troubleshooting tools, like the annotation propagation and so on and so on. Also here, I think it's much better to go into the system, show it what is the meaning of exactly these blocks here. Okay, then going over again to the ADT, I'm switching back to the ABAP perspective, opening my customer order, which is the one, at the Metadata Extension. So first start with that one. So again, as I said at the beginning, I have my consumption view basically. Here, this is this one, and I also put here some annotations like UI annotations here. Basically, what you do here is that you put all the UI annotations into so-called metadata extensions, also other annotations. But again, to show you exactly that one, if you now right-click on the metadata extension, you can say, for example, for the amount here, show me that one open with the annotation propagation. With this tool, maybe you wonder why some fields are not displayed in the correct way, maybe at least not available, not visible, or why they are in a position which you do not expect, basically, And with this annotation propagation, you see where the annotations are coming from, from the I layer, from the C layer, and from the metadata extension layer, and which one is active. For example, I had an annotation for the amount here with a semantics annotation like the currency, and also defined some UI annotations here. And I also overrode them then in the metadata extension layer. And you see which one are really active and where they are coming from. Quite useful. I also have a much more complex sample. This is again an easy one, but let's create a use one that I created in the real world. This is exactly this guy. And if you go to the open view with the active annotation propagation, and if I open the one for the package, package name, then you see, of course, a lot of annotations are in here, and you also see where they are coming from. So all the annotations for exactly this field here, if you have a complex scenario, and believe me, if you have a complex scenario, that is really, really helpful. There's also the possibility that you can also focus directly and search for example, the consumption inside here, where all the consumption annotations are coming from and which one are active, what is the value then in the real world, that is then handed back to the Fiori UI. Quite nice, quite helpful. Then the next one, of course, is the active annotations. So what are all the active annotations that are then being displayed on the Fiori UI? That's also a view available here. It will take some seconds to load. And again, you see here for my scenario, for our customer order, all the annotations that are sent over to the Fiori UI, and the Fiori UI, of course, the Fiori elements will then render them in the appropriate way. And these are the values for that one. Again, this is quite useful, and again, if you have this more complex scenario, for example, this one, if we are opening this in the active annotations, then you have a huge list of information here. And again, believe me, if you're struggling in some information, this is your tool of choice to exactly get rid of the problems, basically. So huge information, a huge list of stuff. And of course, you can also then search for dedicated fields here. If you find out that your application is not behaving like you expected, data is not displayed. Just remember this tool here. Okay, then let's see what I do else have. Active annotations, annotation propagations, Another one, for example, dictionary log. So if I open that one, sometimes it also happens if you activate a view, and we will exactly see that, that this view, of course, is in between of others, or it's used and referenced by others. And if you just go to the dictionary log here, open with the dictionary log, you have an overview about all the referenced views that are maybe touched during the activation. So also, again, this is a small sample here, but believe me, I will show you in a second that if also you have a a bigger one, to have this example here that is really, really helpful if something happens. Quite important here is this is simply an overview here. If you want to see the full-blown dictionary log, you have to move over this C log. There's also Control-click to open. You need to press the Control key, open that log, and then you really see the dictionary log. You might also know from the backend. So if you have some activation errors, maybe this is really also helpful to directly navigate into the dictionary log here, the detailed view to see what's going on, why some stuff is not working or the views are not activated. And last but not least, as I just said, open view with the so-called Dependency Analyzer, also quite useful. You get an overview about the artifacts that are involved. Maybe I open this one here, a little bit more complex. So this is my view again. Then you also have a kind of complexity. So how many database tables and joins basically are in. Again, simple sample, but if I open my view, this is this one here. This one, more complex one. No. This is the underlying projection view. If you open a real sample, open with the Dependency Analyzer, you will see that this is much more complex. The metrics here shows that we have access to 117 database tables. That we have close to 90 join operations here. And of course, if we go to the dependency graph, you will basically see a lot of a huge list of what's going on. And also here, if you might have someday performance issues, maybe look here into that one, because that's a huge number. And maybe you could also ease then the database accesses if you run some day into some performance issues. Okay, that's basically it from my side. So going back to also from the demo wise, the troubleshooting tools. Last but not least, also here for completeness, some information about the debugger. Again, because of the sake of time, and we already run out of time, Rich, sorry about that. Some information here. At least I showed you the postmortem debugger. So also quite integrated into the feed reader. And that's basically it. To wrap it up quickly, the ABAP RESTful programming model helps you to create applications quite efficiently and also quite fast. It's quite cool too. As you saw, it took me, I think, 1 or 2 days to exactly create these 2 applications there. What's really nice. And that's your programming model if you want to create new cool applications in the future. The ABAP development tools is the tool of choice. There is no other way around that. So you have to learn it. I can only encourage you to use ABAP development tools to create your applications. And of course, if you run one day into some issues, go to your ADT and also troubleshoot your application with the ADT tools. And quite new, as I just said, are the ABAP Crosstrace. This is really focusing on the RAP specifica. So if you run one day into some issues, and I'm pretty sure you will, remember that, turn it on, and you'll find some really helpful information what's going on in your application. With that, some advertising slides again at the end. If you want to find out more information, there's also an open sub-course for the ABAP RESTful programming model. Maybe you check out that for do your own education. And with that, I am done. Thank you for listening. Hope you enjoyed it. Maybe you have some feedback. And back to you, Rich.
Wow, that was fantastic. I actually didn't realize how much information we put at the developers' fingertips in the tooling itself. So that was really great. Thank you so much. It was a great presentation. I know that this will help many of our customers, especially those looking to move to S/4HANA in the near future, to not only embrace RAP as the programming model, but also ABAP development tools in Eclipse as well. So thank you for this. This is very, very, very helpful. For the viewers out there, don't forget to check out the rest of the DevToberfest schedule for more information about other sessions that are happening this week. And bye for now. Thank you.
Thank you. See you. Bye.